In this module, we will be discussing how you will graph the data that you have collected and how to use visual analysis to determine if your intervention is successful or if it needs modifications. Collecting data during assessments and interventions allow us to know if our assessments and interventions are successful and to what degree they are successful. So when conducting assessments or implementing behavioral interventions, you will collect a significant amount of data. Making data-based decisions will help you make the best decisions or decisions in the best interest of the client or students with whom you are working. Further, making decisions based on the data will help you avoid making changes to assessment or intervention procedures based on subjective reports. Data should be collected every time you are conducting an assessment or implementing an intervention in order to record how an individual is responding to assessments or treatments. Data should be graphed and analyzed at least weekly in order to monitor progress and make changes to treatment if necessary. There are two main types of graphs that you will encounter in behavior analysis. The first graph that we encounter is the line graph. The line graph represents the change in one or multiple behaviors over time. The second is the histogram. The histogram allows you to compare the proportion of behavior exhibited to other behaviors or the proportion of behaviors exhibited in certain environmental conditions. Interpretation of these two graphs relies heavily on visual analysis. We will cover visual analysis after we cover the steps that go into making each graph. The line graph consists of one or multiple data paths that represent the level of problem behavior over time. The vital components of a graph are the title, X and Y axis, data path or data paths, axis numbering, axis labels, and the legend. The following slides will show you how to create a graph in Microsoft Excel. Because the graph requires both X, horizontal, and Y, vertical coordinates, in order to make a point, we will need two numbers. The first number will place the datum on the horizontal axis, and the second number will place the datum on the vertical axis. For example, in this picture, our raw behavior data is separated into two columns. The first column is the session number, and the second column is the frequency of screaming. I would strongly recommend always organizing your data in this way. Keep in mind, your session number column could be changed to a date if that's something that you feel is necessary. In order to insert a graph, you will need to first click the Insert tab, then select the option highlighted in this screenshot. Be sure to select the XY scatter plot with straight lines and markers. If you choose the line graph, the rest of this tutorial will not work for you. Excel should automatically populate your data into the graph. We will cover what to do in the next slide if it does not, but right now we are going to make some slight changes to our graph in order to make it more readable. First, we are going to delete the grid lines. This is done by double-clicking both the vertical and horizontal grid lines, one at a time, and then hitting the delete button. We will then add axis titles and a legend to the graph by clicking on the Chart Design tab. This tab is only open when the graph is highlighted, and then we will click the Add Element button. The legend can be found in the same menu. Your graph should look similar to this after you have added axis titles and a legend. In order to add another data path, you will first need to enter the raw data in a separate column. After you have placed the data in a separate column, you can add that data to the graph by right-clicking the graph and choosing the Select Data button. You will then click the small plus button at the bottom of the Legend Entries box. After you have selected the data, you will need to enter the title of the data path, the X values, which are your session number, and the Y values. In this case, it's hand raising. Repeat this process in order to create more data paths on one graph. A phase change line in a graph means that some significant change has occurred. An example of the significant change might be a change in intervention or the introduction of a new intervention. A condition line is similar to a phase change line, but it means that a less significant change has occurred. So for instance, this might be a medication change. In order to add a phase change line, we will need to create a new series. Begin by labeling two new columns as X and Y. We will then add this series to our graph the same way that we have added the data path from the last slide. This time, we will label the new data path as phase, and we will assign the X and Y values to the two columns we have just created. We want to put this phase change line between points 9 and 10, so we will put 9.5 twice in the X column and 0 and 100 in the Y column. This should give us a vertical line. We will then need to format the line. By that, we will change the color to black, remove the data markers, and reformat our Y-axis range to 25. Remember to format the data path so that you do not have markers on the phase data path, and that you readjust your Y-axis to a maximum of 25. In order to format the data path, simply double-click on the vertical line. In order to modify the Y-axis, double-click on the axis. Next, we will discuss how to create a histogram. The histogram can be used for many things: graphing preference assessment data, graphing ABC data, graphing trial-based functional analysis results, or comparing proportions of behavior. You will want each histogram to represent one assessment, situation, behavior, or environmental event. Organize your data with the final value in a column next to the title of the data path. We will be making two histograms from this data set. You can see that we are graphing some ABC data for self-injurious behavior. In the left column, we have antecedents and their frequency of occurrence before problem behavior. In the right columns, we have the consequences that followed instances of problem behavior and their frequencies. Whatever you write above the frequencies will be what the graph is titled. For both of the histograms that we develop, we will use the cluster column option shown on this slide. If you have organized your data appropriately, it should automatically populate the chart title. After selecting the clustered column option, your graph should automatically populate like what is seen on this slide. Go ahead and repeat the same process for the consequences dataset. After you populate your second histogram and delete the grid lines, your final product should look something like this. We will now move on to visual analysis. There are three components to a data series that will come into play when we discuss visual analysis. These three characteristics of a data series are the level, the trend, and the variability. Most often when conducting visual analysis, we will be comparing baseline to treatment. This allows us to establish a current level of behavior, and in the baseline, it allows for comparison to the treatment phase. So we want to take a look at the level, variability, and trend of both of those and compare one to the other to see if we should continue our treatment or modify our intervention. The level is the mean of all of the data points in a series. So in order to imagine the level, imagine a horizontal line going through the middle of your data. This is an example of the level of problem behavior. Even though there is a range of 1 to 5 occurrences of problem behavior, the level of the problem behavior for this data series is just above 2. The level is indicated by the orange line on this slide. The variability is the deviation of your data points from the mean, or the distance of your data points from that horizontal mean line. There are two examples of variability here. If there is a lot of deviation, we would say that the data is highly variable. If there is not very much deviation, we would say that the data has low variability. The data path on the left has low variability, and the data path on the right is highly variable. The trend of your data is the increasing or decreasing direction. This is the slope of the data path. Here are two examples of trend. On the left, we have a decreasing trend, and on the right, we have an increasing trend. Behaviors will increase or decrease with different trends. It may be helpful to describe trends in terms of gradual or steep. For instance, the left data series is decreasing gradually, and the right series is increasing moderately. If the frequencies were higher on the right graph than they are right now, we may say that they have a steep increase or are increasing steeply. So, when we're comparing baseline to treatment, we need to be analyzing that data in terms of level, variability, and trend. We should be looking for consistent and recognizable patterns of change. When visually analyzing graphs, always compare baseline to treatment or treatments to other treatments. Be sure to consider all three aspects of each data series. Sometimes you may have a decreasing or increasing trend in baseline. You might see a similar trend up or down in the intervention. If this occurs, be careful about attributing any behavior changes to your intervention. We will discuss this a little more later. Always be sure to examine the variability of data during treatment. We almost always want more stable responding during the intervention phase, meaning there should be low variability. High variability in the intervention phase may warrant modifications to your current intervention. Let's practice some visual analysis. Identify the approximate level of both data series on this graph. Be careful not to confuse the trend line with the level of the data series. Even though these two data series differ in terms of variability and trend, they have the same level. If this were baseline and intervention data, I would suggest making modifications to the current intervention. Take a minute to use the visual analysis strategies we discussed earlier. If Series A is the baseline of problem behavior and Series B is the intervention, would you say that this intervention was successful in decreasing problem behavior? We don't really need the trend lines here, but you can see that the problem behavior was highly variable and had a steep upward trend during baseline. The level in baseline is somewhere between 4 and 5. In intervention, we do have a slightly higher level, probably somewhere between 5 and 6, but there is a steeply decreasing trend and low variability. In all, if this were baseline and intervention data, I would say that this is a successful intervention, and that whoever is implementing this procedure should continue to do so. In this module, we looked at developing two different types of graphs. The first of those graphs was the line graph, and the second type was the histogram. We then talked about visual analysis, where we discussed the three main components of a data series. Level is the mean or average of the whole data path. Variability is the degree to which the data deviate from the slope of the line, and the trend is the slope of the line. The trend can either be increasing or decreasing, and is usually described in terms of gradual or steep increases or decreases.